Hello student, in this article we will discuss about Gauss law. So here the statement of Gauss law, the flux of electric field through a closed surface equals the net charge enclosed by the surface divided by epsilon 0. The flux of electric field through a closed surface equals the net charge enclosed by the surface divided by epsilon 0. Therefore, phi is equal to q upon epsilon 0. So what is phi? So phi is where phi is the flux of the electric field, q is the total charge or net charge within the surface, and epsilon 0 is the permittivity of free space or vacuum. So this statement is called as Gauss law. या ठिकाणी बघा तुम्ही काय केलंय, गॉस लॉचं स्टेटमेंट बघितलंय. हा जो फाय आहे हा फ्लक्स आहे आणि फ्लक्सची व्हॅल्यू तुम्ही काय सांगितलंय, क्यू अपॉन एप्सिलॉन 0. हे स्टेटमेंट आहे गॉस लॉचं. तसं गॉस लॉची एक डेफिनेशन पण आहे, इलेक्ट्रिक फ्लक्सची एक डेफिनेशन पण आहे. आणि या डेफिनेशन मध्ये तुम्ही इथं नोट लिहिलाय बघा, कारण हा खूप इम्पॉर्टंट पॉईंट आहे आपल्या. त्यासाठी लिहिलंय बघा, फाय इज इक्वल टू integration, this is closed integral E dot ds. So always remember that, note that here phi is equal to integration of E dot ds. So one of the formula is phi is equal to q upon epsilon 0. This is Gauss law, and here phi is equal to integration of E dot ds. So now we will discuss some of the applications of Gauss. So one of the application of Gauss law is here, expression for electric intensity outside charge conducting sphere. Okay, so now here consider a sphere. This is sphere of radius capital R, charged to a surface charge density sigma when it is placed in dielectric medium of permittivity epsilon, where epsilon is equal to epsilon 0 k. याच्यात काय करायचं तुम्हाला, की आपल्याकडे इलेक्ट्रिक इंटेन्सिटी हा जो आपल्याला कंडक्टिंग स्पियर दिलाय बघा, जो प्लस साइन दाखवलाय तो है ना, या स्पियरच्या आउटसाइड आपल्याला इलेक्ट्रिक इंटेन्सिटीची व्हॅल्यू काढायची. ओके, त्यासाठी हा पॉइंट आपण पी कन्सिडर केलाय बघा. स्लाइड विल सी हियर द टोटल चार्ज इज गिवन बाय q इज इक्वल टू सिग्मा a. सिग्मा इज सरफेस चार्ज डेंसिटी and a is 4 pi r square. So 4 pi r square is area of this conducting sphere. Okay, now consider a point P here, situated at a distance r from center O. This is center O, so distance from center to point P is r, so this distance is mentioned here. Imagine a concentric Gaussian sphere of radius r passing through point P. So this surface is an imaginary sphere. Okay, imaginary surface. This surface is also called as Gaussian surface. So our aim is to find out electric intensity at a point P. So here the concentric Gaussian sphere passes through point P is called as Gaussian sphere. आता तुम्ही काय केलंय बघा, एक P पॉइंट ह्या सेंटर पासून r डिस्टन्सला लांब टाकलाय बघा, टाकलाय ना r डिस्टन्सला. हे बघा, हे r म्हणजे स्मॉल r पकडलाय आपण. आणि जसं तुमचा पॉइंट P इकडे आहे ना, तसा तुमचा लेफ्ट साइडला पण आहे, व्हर्टिकली अपवर्ड पण आहे, डाउनवर्ड पण आहे, बॅक आणि फोर्थ पण आहे. मग असं एक इमॅजिनरी स्पियर तयार होईल, त्याला आपण म्हणतो गॉसियन स्पियर. ओके, नाउ लेट अस ds be a small area around the point P on the Gaussian surface. Gaussian surface ला तुम्हाला हा P पॉइंटला एक एरिया दाखव. मग आता तुम्हाला डेफिनेशन मगाशी सांगितले मी, टोटल इलेक्ट्रिक फ्लक्स थ्रू Gaussian surface is given by here phi is equal to integration of E dot ds. Okay, now E dot ds is equal to EDS cos theta. So close integral in E ds cos theta, as theta is equal to 0, cos 0 is equal to 1. Therefore phi is equal to integration of ds is equal to E integration of ds. Okay, so here E is constant and ds is variable, so we have put this variable quantity ds in the integration. Okay, now for sphere, integration of ds means total surface area of that Gaussian surface is equal to 4 pi r square. Now put this value of integration of ds 4 pi r square in this equation. So we get phi is equal to E into 4 pi small r square, equation number 2. Okay, काय केलंय तुम्ही सांगा, ही तुम्ही गॉसियन सरफेस आपली जी इलेक्ट्रिक फ्लक्सची डेफिनेशन आहे ती डेफिनेशन तुम्ही वापरली. आणि इथं मग थिटाची व्हॅल्यू 0 टाकली, cos 0 1 आला आणि मग इंटिग्रेशन ऑफ ds म्हणजे टोटल सरफेस एरियाची व्हॅल्यू किती टाकली आपण 4 पाय r स्क्वेअर ही व्हॅल्यू टाकली. हे तुमचं इक्वेशन नंबर 2. नेक्स्ट अकॉर्डिंग टू गॉस लॉ बघा, अकॉर्डिंग टू गॉस लॉ phi is equal to q upon epsilon 0 is equal to sigma 4 pi r square upon epsilon 0. हा गॉस थेरम तुमचा आहे. त्याचा q ची व्हॅल्यू इथं वर नोट केले बघा इक्वेशन 1 नुसार, q is equal to sigma 4 pi r square इक्वेशन नंबर 1. ही व्हॅल्यू तुम्ही उचलली तिथे टाकली. आता तुमचं इक्वेशन 2 बघा आणि इक्वेशन 3 बघा. मग इथं असेल बघा फ्रॉम इक्वेशन 2 अँड इक्वेशन 3 हियर phi तुम्हाला दिलाय, इथं किती आहे e4 pi स्मॉल r स्क्वेअर आणि ही phi ची व्हॅल्यू परत आहे. इक्वेशन 2 आणि 3 इक्वेट करा, वी गेट e4 pi r square is equal to sigma 4 pi capital R square upon epsilon 0. Here 4 pi get cancelled and we get our required equation, that is E is equal to sigma capital R square upon epsilon 0 R square. So this expression is called as electric intensity outside charge conducting sphere. In next article we will see two different cases regarding to what here conducting. First case here, if point P lies on the surface of charged sphere, then small r is equal to capital R. We have equation of E. E चं इक्वेशन इथं लिहिलंय बघा तुम्हाला. मग आपण तुम्ही स्मॉल r ची व्हॅल्यू कॅपिटल R टाका, we get r square get cancelled, we get sigma upon epsilon 0. If point P lies inside the sphere, since there are no free charges, sigma is equal to 0, therefore E is equal to 0. Here now expression for electric intensity due to infinitely long straight cylinder or wire. Now consider a cylinder of radius capital R charged to a linear charge density lambda is placed in a dielectric medium of permittivity epsilon, where epsilon is equal to epsilon 0 k. Now therefore total charge is given by Q is equal to lambda L, equation number 1. Consider a point P situated at a distance small r. Now this is point P which is situated at a distance r from point O. So point O is here. Exactly here the point O is not mentioned in the figure. Imagine a concentric Gaussian cylinder. Instead of sphere we can write here cylinder of radius small r and having a length small l passing through point P. Okay, passing through point P. Let ds be the small area around a point P on the Gaussian surface. Now explanation is similar to that of, okay, total electric flux through Gaussian surface is phi is equal to integration of E dot ds is equal to integration of E ds cos theta, as theta is equal to 0, cos 0 is equal to 1. So this phi can be interpreted as phi is equal to integration of E ds is equal to E integration of ds. Here ds is area of cylinder. So integration of ds is equal to 2 pi RL. Putting this value in this equation we get phi is equal to E 2 pi RL, equation number 2. Okay. Now into Gauss law, here phi is equal to Q upon epsilon 0 is equal to lambda L upon epsilon 0. Q is written here, Q is equal to lambda L. And now this is equation number 3 and this is equation number 2. Again equating equation 2 and 3 we get E 2 pi RL is equal to lambda L upon epsilon 0. Therefore E is equal to lambda upon 2 pi epsilon 0 R. This equation 4 is the expression for electric intensity outside charge conducting cylinder. Next application is expression for electric intensity due to charge infinite plane sheet. So plane sheet is given here. Consider a uniformly charged infinite plane sheet with surface charge density sigma, and as we know that sigma is Q is equal to sigma A or sigma is equal to Q upon capital A. Next consider a Gaussian surface. Now Gaussian surface around a point P. This is Gaussian surface around a point P in the form of cylinder. This total in the form of cylinder having cross-sectional area capital A. So here ds is replaced by capital A and length is 2r. Length is 2r. Now, as this cylinder passes the middle of the plane sheet, so here we can easily find the electric intensity at a point P as well as a point P dash. So here electric intensity P and P dash both are same. So here look at it, as the plane sheet passes through middle of the cylinder, the point P and P dash have same electric field. The total electric flux through the closed surface is given by phi is equal to E dot ds at P plus EDS at P dash. Now here ds is area, but area of the cylinder is constant, so we can write phi is equal to E capital A. So this is nothing but ds or A cos theta plus EA cos theta. Adding these two equations, we get phi is equal to 2EA cos theta. Now as theta, since theta is 0, cos 0 is equal to 1, we can write phi is equal to 2EA. This is equation number 1. Okay, look at here. Now here in this case, this area is constant. Okay, so we can write capital A instead of ds. इथं बघा हा एरिया आहे ना, हा एरिया ds एरिया बदलत नाही, त्याच्यामुळे तुम्ही त्याला कॅपिटल ए ट्रीट करू शकता, कारण बदलत नाही म्हणून. जर बदलला असता मग आपण त्याला इंटिग्रेशन टाकलं असतं. ओके, हे इक्वेशन here equation number 1 as it is written, the surface charge density, and in terms of charge we can write q is equal to sigma A. Okay, according to Gauss law, phi is equal to q upon A. Here q is equal to what? Sigma A upon epsilon 0. Now equating again 1 and 2, from 1 and 2 we can write 2EA. 2EA is as it is equal to sigma A upon epsilon 0. Here AA cancelled and E is equal to sigma upon 2 epsilon 0. This is equation number 3. Up to this, here we have explained Gauss law and its 3 applications.